right, so here's another example. Not so straightforward this time. I've got hydrochloric acid mixing in water. And we know that hydrochloric acid will mix in water because they are both polar substances. The trick comes here is to decide which one is going to be the acid and which one's going to be the base in this situation. Well, intuitively, it makes a lot of sense that hydrochloric acid, HCl, would be stronger than water, but how do we know that? So I'm going to go back all the way to whatever month that was. I think it was maybe November. And remember our Lewis structures. So here's my Lewis structure for hydrochloric acid that has one massive dipole moment going that way because chlorine is more electronegative than hydrogen. And here's my Lewis structure for water, which is also very polar, where oxygen is a lot more electronegative than both hydrogens, but there's two dipole moments. And both dipole moments are kind of pointing in the same direction and still have this way of canceling each other out a tad. So I can say that hydrochloric acid is more polar than water. And even though they both contain hydrogen, I can say in this case, hydrochloric acid has to be the acid. So let's fill in our general prescription here. I've got HA to make, in this case, it's going to be a extra spectator ion with one of the H's. I'll just call that X. And then the OH, because remember this is HOH, the OH is going to be my B. So I'm going to end up doing something a little strange here. I'm going to end up donating this hydrogen or its proton to the H2O, and look at the species that I create. I create something called hydronium. Hydronium is water with an extra proton, and the chlorine will be out there by itself. Another way to write this is going to be H plus H2O plus Cl minus. Both of those ways are completely legitimate because the hydrochloric acid will dissolve into the water because they're both polar substances. So what I've got here is hydronium mixed with the chlorine anion to be in equilibrium with hydrochloric acid and the water. Now, what's going to be my conjugate acid and my conjugate base? My conjugate acid in this case is the one with the extra hydrogen. So hydronium is my conjugate acid, and my conjugate base is going to be the chlorine. And in this version here, this is going to be my conjugate acid, the hydrogen. My conjugate base would be the chlorine again. And water is basically, again, my spectator, kind of like what it was over here. Either one of these ways is correct. Whatever way makes more sense to you is going to be the way you should do it. And hopefully this helps.